Hi folks, Harry Frank from Red Giant here, and in this tutorial we're going to continue our discussion about trapcode form, and we're going to move on to two other base form shapes. We've been dragging along talking about box grids and box strings and mixing in other topics to integrate these. But to speed things along, let's talk about both sphere layered and OBJ base forms. OBJs were added in Form 2.0. And up until then, we basically had these three shapes right here. We had two different types of boxes and then a sphere. So let me set this to sphere. And this might look pretty much like you expect. It is a sphere. It is layered. It has 3 layers by default. I could set this to 1 layer or as many layers as I want. The spheres are evenly distributed inside the size that we define right here. So if I set this to 500 by 500 by 500, the spacing of the spheres will be determined by the size that you determine and the number of spheres, evenly divided inside that size. Now, what can we do with spheres? Well, there's a couple basic things that we can do just to get your feet wet. One thing I use spheres for are star fields. So if you have a space scene that you are either compositing using camera data from another application or creating it entirely within After Effects, Form is a great way to create this sort of starry field. And let me show you just quickly how to set this up. Well, I'm going to click on Reset so we go back to our default settings here. So I'll set this to Sphere Layered. Right now, I'll just set this to 1 sphere. And I'm going to set the size to a very large size. So let's say 12,000 by 12,000 by 12,000. Now, I'm not seeing a whole lot. First, let's turn up the particle size until we see the particles off in the distance. There we go. Now, if I move my camera around, we can see that we have these perfectly aligned grids of dots, which are going to be our stars. But stars are not evenly divided like this, so we need to randomize things. I'd like to randomize both the size, opacity, and position of the stars, but I don't want them moving. So I don't want like a fractal field moving through these things. I just want random position. So when we're dealing with random size and opacity of the particle, that's a good use for the particle section. And we can randomize the size by turning that up. Randomize the opacity by turning opacity random up. And to randomize the positions of these, I'm going to go into disperse and twist. We spoke about this in the strings lesson, where the disperse randomizes the positions of the strings. But when we're dealing with base forms that are not the strings and are either box grid or sphere layered, disperse randomizes the individual positions of the particles. So if I turn up disperse, it's going to randomize the positions and make these feel, well, basically like a star field. If I turn the particle size up a little bit more, it's starting to get there. Maybe we want more stars along X and Y. So if I move the camera around, you see you have a pretty decent star field. We can actually set a couple different layers and we'll end up with a little bit of parallax as I move the camera around. Now keep in mind that inner sphere of particles is a bit closer to the camera because we added one and now the spheres are distributed halfway along that size. So now I have a set of spheres that are 6,000 pixels from the camera. Actually, I should say 3,000 pixels from the camera because we're right in the middle and the distant one is about 12,000 pixels away, depending on how much I've moved my camera. The inner one is 6,000 pixels away, and if my camera is right in the middle, then it'll be 3,000 pixels away. So, long story short, you might want to just take the size and bump it out. In fact, maybe you just want to work with size Z and squash your universe in like so. You could make it a little bit more dense in the middle. Make it feel like a kind of a galaxy. And if you want to thin it out a little bit, you can do that. But this is a very cool way to make a very quick rendering, fully integrated star environment if you're creating some super awesome space scene. In fact, if you want to dress it up even more, you can throw some sort of lens flare in there like Null Light Factory. If I zoom around and find where my light is, there it is. Here you go, instant space scene. So that's a very easy use for the form sphere. What else can we do with it? Well, another cool thing that we can do with the sphere layered is work with the built-in audio reactor. Audio reactor, if I close these sections up, is down here just above disperse and twist. This is a very unique function. You don't find this in any other Trapcode product other than SoundKeys. SoundKeys is a utility also made by Trapcode. That allows us to look at an audio file and generate keyframes based on very specific frequency ranges and thresholds. So if I take some music that I have in here and go to SoundKeys, define that audio layer, we'll see a sort of a spectral map of the audio, and I can fine-tune this and hone in on very specific frequency ranges, like the bass drum down here. So to integrate SoundKeys with other plugins, what you have to do is go down here and hit apply, and this will write your keyframes, and you can either copy and paste the keyframes or link them to other layers using expressions. And although not complicated, it does add an extra step. So the cool thing about Form is it has that same type of audio reaction built right into the plugin. So let's set this back to our sphere. Go to base form, sphere layered. We'll set this to 1, and also let me reset my camera. I'll set this to maybe 500 by 500 and leave it a little bit squashed so we have this sort of disc kind of shape here. And let's add some more particles. Okay, so now actually I'm going to add SoundKeys back in here real quick. Just to have a reference to explain this. So if I twirl open Reactor 1, we'll see all these different controls in here. But the first one you want to focus on is this frequency control, because this is going to define exactly what we're looking at in the audio file. So unlike the built-in After Effects expressions, which converts the amplitude of the audio file into keyframes, Form and SoundKeys are going to look at very narrow ranges of the audio spectrum. So what we can do is isolate elements like the bass drum or the snare drum. So what I'm seeing right here is a bass drum. So if I'd like to map a parameter in Form to that bass drum, I can isolate that frequency and assign it using the audio reactor. Now what we're lacking in Form over SoundKeys is that visualization of the spectral map. So we have to know a little bit about what we're doing. So if I go into the audio react section here, and I'll define my audio layer, we have 5 different audio reactors in here, which should be more than enough for one layer of Form. The first parameter you're going to want to focus on is this frequency right here. 100 hertz is fairly low. It's at the upper range of what we consider low frequencies. If I'd like to isolate exactly where that bass drum is, let me assign something that would be mapped to this and see how close we are. So let's say we're going to map Reactor 1 to the transform world scale. Remember I mentioned transform world, where we can transform properties for the entire universe of this layer of Form. So if I set this to transform world scale, this whole thing will scale up. Now, if I set this to sphere 1 or sphere 2, you might think that this would scale this sphere up or down. But this is talking about a feature that we used in the first lesson, which is the spherical field. So what this is doing is offsetting the size and strength of the spherical field, not the size of our base form. So it's critical to know that. So I'm going to set this to transform world scale. And it looks like we're hitting something pretty close right here. Now, it could be said that computers calculate and process things a lot faster than our brains, but our brains are a lot smarter than computers. So when we listen to this music, we clearly hear where that bass drum is. and it's a no-brainer where that bass drum falls. But to a computer, it's seeing a lot of other stuff that's going on around that frequency range. So sometimes we need to kind of clean that up and focus specifically on where that bass drum is. So we might need to maybe bump the frequency down just a little bit. I'll set this to 60 hertz, and I'll raise this threshold up to maybe about 20. Basically, what I'm trying to do is filter out some of that extra noise and other stuff that is going on, but the computer certainly is. So let's see what we're... Looks like we've got some fine-tuning to do. I'm going to bring the strength down by 50%, so it's not jumping around so much. I'm also going to bring this width down, so that's how far on either side of this frequency band that it's going to look. So the less this width is, the more narrow that frequency band is. Now for a bass drum, I think that's pretty good. I can set this down to a fairly low value. And maybe I'll bring this threshold up even more. The threshold, if we look at the sound keys visualization right here, let's see if I set this to right here. So this is our frequency band. This is essentially where we're looking, how wide that frequency band, or the width would be this control right here. So how many of those frequencies we're examining. And this would be the threshold, so the point at which it starts. So this essentially to our reactor is 0. Everything below this is ignored. It's kind of like a gate control. So if I set this to right here and I look at this frequency band, even though there's stuff going on here, I am not going to trigger the audio reactor until this threshold falls below where that frequency is resonating. So let's turn sound keys off and check out what we've got so far. Looks like I can bring the strength down even more. That bass is pretty loud, so we don't need to crank it up that much. Now, one thing I'm seeing is that our reaction is lagging just a little bit. Very important thing with the bass, you cannot be behind the beat. So let's nudge this time offset to a negative value. So we'll bring this back just a little bit so that our visual aligns with what we're hearing. Getting pretty close. I'll set this to 0.04, negative 0.04. So we have a little bit of adjustment there so that the beat falls right on top. Now, I think that's pretty cool. We have all different types of things that we can control in here. We can control fractal strength. We can control particle size. And don't forget, we have multiple audio reactors. So I could have particle size and transform world scale. Now, all the way here at the bottom, after we've calculated all this stuff, we can actually delay everything that's being applied as a reactor to this bass form. So I can say delay this direction from left to right and set a delay across left and right of a numerical time that is, let's say, 0.1. Now what we're going to see is that reaction will sweep across this bass form from left to right. Now I'm going to leave this set to 0. I'd like this bass drum hit to just kind of thump like that and not be sweeping across left to right. But we'll put another one right next to it that is going to follow the, we'll call it the snare drum. I mean, it's electronic, but we'll just call it the snare drum. And that's going to be on beats 2 and 4. So this is on beats 1, 2, 3, and 4. And the other one over here will be 2 and 4. And we'll do this automatically using the audio reactor. So let me relabel my layers here. This is going to be the sphere, spelled correctly. And I'm going to duplicate this. And we'll call this the form cube. And you should be saying, wait a minute, a cube? How are we going to do a cube? Well, we're going to explore that other option that I spoke about, which is the OBJ model. Like I said, this is fairly recently added to Form 2.0. If you don't see this, make sure you get updated to Form 2 because the OBJ model option opens up a universe of possibilities for Form. We're no longer limited to these 3 options, and we can import any sort of OBJ and map particles to the UV points of that OBJ. So if I set this to OBJ, it disappears because we need to define an OBJ to be used with form. So where are you going to get an OBJ? Well, fortunately, included with form are a whole slew of OBJs that are a lot of basic primitive shapes to get you started. So if you missed those OBJs the first time around, simply go to redgiant.com/product downloads. Locate the Trapcode Suite installer for your particular operating system. And once you download it and unzip it, you'll have the installer and uninstaller. You don't need either of those. Go to User Guides and Extras, Product Presets, OBJ Files. And there's about 50 OBJs in here of different primitive shapes and weird things that I designed. And also there's an OBJ sequence folder that has, OBJ sequences. We'll talk about that a little bit later. But I mentioned we wanted some cubes. So let's go up here under C for cube. And there's 3 different cubes, 4, 8, and 16. The number essentially refers to the density of the original OBJ. So a lower number means fewer vertex points or vertices, and a higher number means more. Because form renders particles at each vertex point, a higher number means you're going to have more particles. So let's just import all 3 of these. And I'll drop cube 4 in, and we can see that it's an OBJ for use with Trapcode Form. Now, notice what we just did. We just imported an OBJ into After Effects. When you install Trapcode Form 2.0 or higher, one of the things that is installed is an OBJ parser. A parser is basically a plugin that tells a program what the heck to do with a certain file format. In the case of an OBJ, we can read what's inside, all the points and UVs and all that kind of stuff. After Effects can tell Form what to do with all this data. So if I go to my Form cube here, and actually let's move this over. So right now it's a sphere. Let's set this to OBJ model. And once we set that to OBJ model, we can go into our OBJ settings and set the 3D model to that OBJ right there. We're not seeing a whole lot. Let's go to our particle settings and turn up the particle size. There we go. If I rotate this around, we'll see that's not quite a cube. And the reason it isn't a cube is because we've set this to uneven dimensions. So we have 500 by 500 by 200. That's not a cube. Let's set this to 300 by 300 by 300. There we go. Now, if I swap out that cube 4 for cube 16, we'll see we'll have an even denser set of particles, which I think is what I want here. Now, we can see that front and back side of the OBJ. And one way to work with this is to go to the visibility section down here and work with the far vanish. And essentially what this does is set two distances. One is the point at which particles will be completely invisible, and the other point is where the particles will start to become invisible. So we can create basically like a fall off so that we don't see the backside of those particles. Because this is downstream from everything, including the world transform, we can flip this thing and rotate it around, and we'll never really see that backside of the cube. That is, unless our camera actually moves and changes the distance. Now we can get tricky and link a null object to the distance of the camera and calculate that distance and map that distance into the far vanish and all that kind of stuff. I actually did that in another tutorial in a quick tip, and we'll post that link in this lesson so you can take a look at working around that camera distance limitation. My camera isn't really going to be moving here. It's just going to be sitting still, and we're going to be watching these things dance to the beat. So I'm not going to worry too much about that camera thing. Now, my styles are kind of mismatched here. I got this cube, which has these fairly large particles, and I have this sphere, which is fairly dense with very small particles. I'm going to make this match up a little bit better. So I'm going to set my particles in X and Y to be a little bit less, and the size would be a little bit more. And I'll also do the same thing with this one. Let's go to visibility and set that far vanish to 800 and maybe 1200 or so. That seems to work. Also a little bit of color here. So let's go to Form Cube, and let's set this to something yellow, and maybe the sphere will be something kind of green. So I briefly showed you that reactor delay and the audio reaction. So right here we have this left to right kind of thing. So I'd like to actually apply that to this cube, but I'd like to map it to a different part of the spectrum to get that snare drum on 2 and 4. And that's going to be a lot higher. So I'll go back to reactor 1 and set my frequency a lot higher. Now, I've rehearsed this lesson, so I'm not going to pretend that I know exactly that 6,000 is the exact frequency that it needs to be. I can say that we know it needs to be higher, and then you'd have to experiment to find exactly which frequency band reacts to that snare drum hit. But 6,000 is right about where it's going to be. But here's the thing, is it's going to be a lot less strong. That bass drum is a lot louder, a lot heavier. But the snare drum is actually going to need a lot more strength to react. So I'm going to take the strength and turn it way up. And it kind of stutters a little bit. So let's turn this threshold up even more so we can really just isolate when that snare drum hits. There we go. I'll take this width down even more, maybe to like 5. Looks like we got it pretty close. I'll set this delay to work on the cube. So it's going to delay that scale across the particles from X left to right. It's a cube, so it doesn't really matter really if we go X left to right or right to left or top to bottom, whatever. It's a cube. It's basically going to go from one side to the other. Let's quickly do something else to react to it. So let's add a little bit of displacement of the fractal here. So not much, maybe 15 or so. And let's go to reactor 2, and we're going to copy some of these settings. So I'll just copy this reaction. The frequency is going to be 6,000. The width is going to be pretty narrow. The threshold is fairly high, 56. Strength, well, we'll work with the strength. We'll experiment with that. And I'm going to map this to the fractal. So we'll control the fractal strength over left to right. And let's turn this fractal up a little bit. And let's do the same for the cube. So let's go to fractal field, turn up the displace. Now, the important thing to remember with the audio reactor is that it's not going to do anything unless we've actually turned up that parameter. So we're not going to see any displacement of the particles due to the fractal field unless we've actually set the displacement to be something above 0 in the fractal field. The reactor just kind of acts as a throttle to control how much of that actually ends up being applied. So let's copy these settings here real quickly. 60, 20, 30, 20. We'll obviously raise that strength up. Let's set this to fractal. And maybe we'll set this to delay. I don't know. So that's going to go left to right. Did I rotate this around? Oh, no. Set that to left to right. Maybe with this fractal, I'll set the delay to be applied to the fractal influence. And on this cube, I'm going to add a little bit of freeform rotation. So let's go to world transform. And I'll just do this with a couple simple expressions. Time times 30, and this other one will be time times 36. So basically, this will just set this cube into a free rotation. But I'll leave the sphere kind of as is. Maybe on this sphere as well. Let's go into reactor 3. and set this to particle size, 60, 20, 30, 20. Map to particle size. And turn up the strength. Actually, let's delay that too. I think that'll look pretty cool. Now maybe I'll set the sphere into a free rotation as well. So I'll set this so that it is actually spherical, and let's go into world transform, do the same thing here, X and Y, time times 30, time, I'm just setting these to slightly different values so that they rotate just in slightly different ways. Now it's starting to look like a disco party. Now, let me share one really cool thing that I've actually discovered while I was working on this. This whole quick map section is a really, really useful section, and I want to show you something cool that you can do with it when we're working with the audio reactor. Now, I showed you the quick maps and how you can map opacity and color over a certain axis. The concept being we have a one-dimensional map and we pick one of the three dimensions to apply it to. Below the opacity and color maps, we have three separate maps that allow us to control different parameters like size, opacity, fractal strength, that kind of thing. So let's say I set this to size and set this map right here that has more value on one side and less on the other, and everything in between. And you can see we have decreasing particle values over the x-axis or the y-axis, which is kind of rotated around, or the z-axis front to back. Inside the quick maps is also a control of the AudioReact. So the AudioReact kind of acts as a throttle to other parameters, and then the quick maps can actually act as a throttle to the audio reactors. Now, why would you want to do this? Well, let me show you a cool example here. I'll set this to X, and I'm just going to draw kind of a crazy curved map in here. Now let's set this to a spot where the audio reacts. So you can see what we're doing is throttling the audio reactor so that over the x-axis we have more audio reaction and less audio reaction depending on how this is mapped. Now let's do a quick preview of this. I mentioned that because I've only recently discovered that we actually have control over the audio reactors inside the quick maps. We'll get into more detail on the quick maps in a later lesson. My name's Harry Frank. Thanks for watching.